Hi guys, welcome to the Introduction to Maps in Folium and Python course. In this course, we will be touching on a couple of topics ranging from interactive maps, which is what you see before you, Folium, Python, Pandas, Selenium, and Jupyter. So what interactive maps are? They allow the ability to create layers of information that can be shown or hidden at a click of a button. So if I click on the map on a point, it reveals certain information. Okay, like for instance here, it reveals the name of that suburb and the amount of water consumption in kiloliters. It includes addition of text boxes to data points, which is what we have just seen, that show up when clicked to give a quick summary or description. Zoom functions that allow users to focus on either the details of a particular region or to gain a quick overview of a wider area. So you can use the zoom functions of the interactive map to gain a view of the wide area, or you can zoom in to a specific area. Data can be quickly updated, and these updates are transparent to the users. Points of a map can be linked to external supporting documents such as images, videos, or graphs. So Folium is a mapping library that builds on the data wrangling strengths of the Python ecosystem and the mapping strengths of the leaflet.js library. It was built to help people visualize geospatial data. It can help you create a map of any location in the world. So that is the library that we will be using for our mapping. So it combines some of the Python language features as well as some classes from leaflet.js. So our programming language that we will be using is Python, which is just a programming language that can do whatever you want it to do. And then we are also going to use Pandas. So Pandas is a Python library that is used for data manipulation and data analysis. It can also be used as an ETL tool. And then we'll also be using the Selenium library. So Selenium is an open source tool that is used for automating tests carried out on web browsers. You can automate clicks, filling of forms, etc. Basically anything that you would do to interact with pages, Selenium can do that without human intervention. And then we are going to be working in an environment called Jupyter. So Jupyter Notebook is an open source web application that allows you to create and share documents that contain live code, equations, visualizations, and narrative text. Uses include data cleaning and transformation, numerical simulation, statistical modeling, data visualization, machine learning, and much more. So the types of maps that we will create in this course range from heat maps, point maps, choropleth maps, and we will also be covering the consumption of external web map tile services. So the web map tile services will allow us to consume tile base maps that we can use in our application using the web service URL. We will also be covering different use cases, ranging from, we'll be mapping unemployment rates, we will be mapping dam levels, and we will be mapping water consumption. And then when we are done, we will export and share our maps in the form of an image or in the form of an HTML web application. So I'm going to show you what the exported version of our maps will look like as an HTML web application. So here is one of the many maps that we'll be building. So as you can see it's exported and it's interactive. So you can, if you want to share the map, you can just send the HTML file to someone and they can view the map that you created. And then we'll also be creating this point map here, where we have a bunch of points per suburb and we classify them with the different colors. And not only that, but we'll also be covering the consumption of web map tile services. So that helps us build multiple base maps or layers like we have here. If I click on one, world ocean base, and here's another one. So as you can see, we'll be consuming multiple web map tile services. Okay, and if you share this map, all these layers, these points, and the data will be included in HTML. Okay, and then we will also be building a choropleth map where we'll be mapping the unemployment rate per country in the year 2018. Okay, and we'll also showcase the consumption of a beautiful tile from a web map tile service. So yeah, that is basically some of the few things that we'll be doing in this course. And before you get started, you might want to visit Anaconda. So Anaconda will basically contain our entire development environment, Jupyter notebooks and Python, as well as most of the libraries that we will be using for data science will be included in Anaconda. So you go to download, and then you select Windows, which is my operating system, or you can use Linux or Mac, and then you just download and install the environment, and you will be able to have a Python environment to work in, as well as Jupyter Notebook. So thanks a lot, guys. That marks the end of the introduction video to this course, and I hope you guys will enjoy it and learn a lot from it. So thanks for tuning in. I'll see you guys in the next video. Hi guys, welcome back to Introduction to Maps in Folium and Python. So the first thing that we are going to do is we are going to download our data set from GitHub. Open up a new tab and then search for GitHub Ebesis. Okay, click on the first link. Go to the WaterWatch repo and then click on the dataset and then click on download. So this will download the dataset, which is an Excel file, to your downloads folder, or wherever you have specified your downloads to be downloaded at. Just make sure you have the location of that file, because we are going to use it when we import it into our code. And the next thing that we are going to do is we are going to install the Folium and Pandas libraries. So I'm just going to go through the motion of doing that. I've already done that, so you will see the message that will be displayed will tell me that those libraries are already installed, but for you it will actually install the libraries. So it's exclamation mark pip install. The first one that we will install is Folium, which is our mapping library, and then we are going to install Pandas, and then shift enter. Okay, as you can see, that asterisk has disappeared, so it means that our cell ran successfully, and it shows me that the requirement is already satisfied. So I already have Folium and Pandas installed on my machine. So I'm going to delete the cell, and then I'm going to clear this and just say shift and enter to remove it. Okay, The next thing that we are going to do after we have downloaded our libraries is we are going to import those libraries and use them. So the first library that we will be importing is Folium. So let's import Folium. Let me just zoom in case you guys are using a smaller device. Okay, so it's import Folium and then import pandas as PD. Shift enter. Okay, so no error messages has popped up. So our libraries are imported successfully. And the next thing that we're going to do is we are going to import our dataset, which is downloaded from GitHub. And make sure you have the location. Like right click on the file, go to properties, and then copy the location to that file. And then we are going to store it in a pandas data frame that we will call df suburbs equals pd.read excel, and then I'm going to specify the location of that file, which is in my C drive. In my downloads folder. And then the name of the file. Okay, and then I need to specify the sheet name, which doesn't have one, so we are just going to say sheet 1. Okay, and then we are going to print the head of our data set, which will be the first 5 records, right, of our data frame. So it's df suburbs dot head, and then shift enter. And if our data set was imported successfully into pandas, we will be able to print out the first 5 records, the header of our data set, and the head, sorry. And as you can see, all our fields are here, and the top 5 records are printed successfully. Okay. And the next thing that we are going to do is we are going to explore this data, right? So we are first going to print out all the columns. Okay, as you can see, it printed them out. So we have suburb, that is the one that we will need, which has the name of the suburb, and this field contains the kiloliter consumption value. And then we are also going to use the latitude and longitude values to pinpoint the location of that suburb on the map. Okay, so the next thing that we are going to do is we are going to print the shape of our data frame, which is the dimension, the rows and columns, row by column. So that's df suburbs dot shape. As you can see, we have 121 rows in total and 7 columns. It's 1, 2, 3, 4, 5, 6, 7. Okay, and then we are going to view basic statistics of our data frame, which is df.suburbs.describe. Okay, and then shift enter. And as you can see, pandas will give us some basic statistics of our data frame. It will tell us the min, max, the mean, standard deviation, the count. So we have 121 records, that is correct. And the maximum kiloliter consumption value is 13 kiloliters, and the mean is about 8 kiloliters. So it looks correct, right? And then once we have that, the next thing that we are going to do is create our map. So I'm going to show you how to create a basic map in Folium, and we are going to use that map in this course. So let's say map OSM, which stands for OpenStreetMap. That is the default base map that you get in Folium. Folium dot map, and then you need to specify a location equals, which is a list of the latitude and longitude, which is 33.925.18.625. So this is the GPS location of the city of Cape Town. And then we specify a zoom start, which is how far in do you want to zoom into your map once it's loaded, and we are going to say 10 steps in. Okay, and if I have not made any syntax errors, it should display our map. So we press enter and then map OSM and then shift enter. As you can see, we have easily displayed our map, right? And it's interactive as well in just 2 lines of code. That's what makes Folium very powerful. Okay, and yeah, so that's it for this video. I will see you guys in the next one. Thank you. Hi guys, welcome back to Introduction to Maps in Folium and Python. In this video, we will be plotting markers and styling them on our map. But before we do that, we are going to add a second base map, which we are going to call map doc. So the name of this base map is called cartodb doc matter. So let's add it. It's map doc equals folium dot map. Specify location, our latitude and longitude values. Okay, and then we are going to add an additional argument, which is called tiles. And then we are going to specify a specific tile that we want to use as our base map. So the name of this tile is called cartodb doc matter. And then we are going to specify a zoom start, and we are going to say zoom in 10 times and then load the map. Okay, so there is a difference in our arguments for loading this map versus this one. So the only difference being the tiles option. So by default, when you don't specify a tile, you will get the OpenStreetMap as a base map. But if you want to change that, you can specify a specific tile that you want to load. In this case, cartodb doc matter. Okay, and you can also specify a custom web map tile service, and it will pull that from whichever website the map tile service is hosted on, and then it will load it as your base map. So now let's print this map, or let's display it. As you can see, we have now loaded the cartodb doc matter tile as a base map. Okay, so now the next thing that we are going to do is we are going to prepare the data so that we can plot our markers in their respective GPS coordinates or location on the map. Okay, the first thing that we're going to do is we are going to create a separate data frame which will contain our latitude and longitude values. So it's df suburbs, and then we are going to call it locations equals df suburbs, and then we are going to take the latitude and longitude field, and that will be our new data frame that will derive from df suburbs. So it's latitude and longitude. Okay, so once we have that, let's print it and see how it looks. So as you can see, our DF suburbs location data frame has only the GPS coordinates of each suburb. Okay, let's comment that out, leave some space. Okay, the next thing that we are going to do is we are going to convert that data frame into a list. The reason why we are going to do that is because we want to be able to iterate through each record of the data frame. So it's easier to have a list, and we can use the iterating functions of a list, right? So that when we plot the markers on our map, we will plot each and every one per iteration of that list. Okay, so let us call it suburbs location list equals df suburbs locations dot values dot to list. Okay, and now we want the size of that list so that we know how many times are we going to iterate through it. Okay, so we are going to get the size of the list, and then we are going to store it in a variable called suburbs location list size equals len suburbs location list. Okay, so this is going to give us the size of that list, meaning it's going to count each element inside that list. So if there's 20 elements in the list, the size of the list will be 20, for instance. In this case, the size of the list will be the row count of our data frame. So now let us print the size and see how many records we are working with here. It shouldn't be a lot because each record is a unique suburb. Okay, it appears I have a syntax error. Okay, there it is. Okay, so now we can see that we have 121 records that we are working with. So that's 121 unique suburbs. So there will be 121 markers plotted on our map. Okay. So our data is ready, and now we can plot each marker on our map. So we are going to iterate through the list 121 times, and then we are going to plot each suburb on the map. Okay, so it's 4 point in range. So each marker is a point basically on the map. Suburbs, let me see. I don't want to make any more syntax errors. Autocomplete. Okay, so 4 point in range 0 to suburb location. Again, I made that mistake. Location list size. Folium dot marker suburbs location list point dot add to map OSM. Okay, so for each iteration, we are going to take the GPS coordinates, which are stored in point, right, of the suburbs location list. And then we are going to add that point to our OpenStreetMap map or base map. Okay, so let us add a marker on our dark matter base map as well, so we can see how it looks on there. So add each point in each iteration to the base map, which we call map dark. Okay, so it's as easy as that. And now we are going to first print or display our OpenStreetMap, and it should have each and every one of our suburbs plotted as markers on the map. Okay, so as you can see, we have each suburb plotted on our map. In the meanwhile, it's only the marker, it doesn't really tell us much. It's only the GPS coordinates of each suburb as we have specified, and it's 121 of them. Okay, and now let us see if we can plot it, if it was plotted on our dark matter map. Okay, as you can see, here it is. We have successfully plotted our markers on the map. Okay, so now the next thing that we are going to do is we are going to add a pop-up message or a pop-up box with the name of the suburb, so that when you click on each marker, you'll be able to see the name of that suburb popping up. Okay, so in order to do that, the code is kind of still the same, but we are only going to add another field for suburbs, which is the name of the suburb. So let's do that over again for educational purposes, but otherwise I would just be copying it and pasting. So it's point again in range 0 to the length of our suburb location list, or the size. Okay, and then Folium dot marker dot suburbs location list, and then we are going to take each point in each iteration. So each point is a unique combination of a latitude and longitude value for each suburb. Okay, and then now we are going to specify a second argument called pop-up, and we are going to say pop-up equals df suburbs. So now we are using our data frame, and then we are going to specify the key, which we are going to call suburbs. So this is going to use the suburbs field in our df suburbs data frame, which will contain the name of the suburb. So it's suburb, and then the value will be the point, right, which is the GPS coordinates for that suburb name. So it's point, and now we are going to add to map OSM OpenStreetMap, and then we can repeat that and then add it to our dark matter map. Okay, and the next thing that we are going to do is just print it again. So let's start with OpenStreetMap. So now if we click on each marker, we should be able to see the name of that suburb. So as you can see, there it is, right? So our code works, and it was that easy to do. So now let us also display our dark matter map and see that we can get a pop-up box displayed when we click on a marker. Okay, and there we are. Right? So the next thing that we are going to do is we are going to change the icon of the marker, right? So now we are going to introduce some styling. Okay, so again, it's 4 point in range 0 to 121, suburbs location list size, and then we say Folium dot marker suburbs location list. Take each point in that list and plot it, and then pop up is the suburb name, which we get from the suburbs data frame. And we specify a value of point, which is the GPS coordinates for that suburb name, so that the pop-up gets displayed at the same location as the marker. Okay, that's why the point is there on both properties or arguments. Okay, and then we are going to then introduce another argument, which is called icon, right? So this will allow us to specify a custom icon besides this dot that you see here. So we say Folium dot icon, and then we specify the color so this will be the color of the entire icon. Right now it's like a light blue, so we're going to change it to like a dark blue color. So you say color equals dark blue, and then we are going to change the color of the icon. Actually, we are just going to specify it. That's the right color at the moment. So we say icon color equals white. Okay, and then we are going to specify the icon type, and we are going to use tint. So tint, if you are familiar with web development and HTML, Bootstrap, and Font Awesome icons, so the icons that we'll be using are called FA icons, which I think are maintained somewhere. I don't know if they're maintained by Google or whoever, but it's a very well-known icon library. So what's happening is that Folium handles the HTML code in the background. So all we need to do is just specify the name of that icon, and it will create the equivalent HTML code in the background. So we say icon equals tint. So tint is a like a droplet. It's a picture of a droplet. So that will specify water in our case. right? Okay, and then the angle where we want the icon to be displayed, and we say at its default location, which is at 0, 0, x equals 0, y equals 0, and then the prefix. So remember, this is an HTML tool, so FA icons is an HTML tool, so we need to specify FA for font awesome. If you have done some web development, then you will understand why. Okay, and now we can add all of that to the map. OpenStreetMap. We're going to copy this entire line here. And we are going to call this map doc. Reposition that. And then let's display our OpenStreetMap first. Map OSM. And now what you should see is that our icons are now styled. So you can see we changed the color to a more dark blue type of color, right? And we also changed the FA icon, which is called Font Awesome Icons, right, to tint, which is a image of a water drop, right? So you can change that as well. Like I said, if you're familiar with HTML development, then you might have come across FA icons for sure. Let's see if I can still remember some of them. Let's use a plus. There was one called plus. Let's see if that works. It should give us a plus sign. As you can see, there it is. So what you can use this for is to classify different icons as different features on the map, right? So maybe you can have, let's say you're plotting different animals in a certain cluster or location, then you can specify different icons for representing each animal, for instance. Okay, and yeah, that's about it for now. Let us see if we can display this in our doc matter as well. So it's map doc. As you can see, here it is. Right, so we have added our icons and we have styled them. So I will end the video here, and thanks a lot for tuning in. I'll see you guys in the next video. Hi guys, welcome back to Introduction to Maps in Folium and Python. So we'll be continuing with what we did in the previous video, where we edited the icons or our data points on our map. So what we'll be doing now is we'll be introducing some classification. So we will have threshold values, right, for the amount of water consumed by each suburb. So if a suburb has consumed less than 5 kiloliters of water, then we will give that data point a green color. So each suburb that has consumed less than 5 kiloliters of water will be represented by the color green. And if a suburb has consumed more than 5 kiloliters of water and less than or equal to 8 kiloliters, we will give the color blue. So 8 was the mean consumption value, right? And if the suburb has consumed more than 8 kiloliters of water, we will give the color red, meaning that that is too much water consumed. Okay, so we'll be using the colors blue, green, and red. So let's add the code that will classify our consumption values. So one thing to notice is I just changed my icons back to tint from the plus icon. So you can do that if you want to as well. So let's add the code classification 4-point in range 0 to the length of our suburb location list. And now we are going to add the threshold 5 with an if statement. So we say if df suburbs, and then we are going to get the field that will give us the kiloliter value of water consumed by that specific suburb. So that field was called OCT 2017 /NKL /month. And then we are going to get the point value that is associated with that kiloliter value. And then we say if that suburb that has consumed that amount of water, right, which is located at this point, if that value is less than 5, then we are going to add that point as per usual. We're still going to add a pop-up. So the pop-up will display the suburb name, which is fetched from the suburb field. And then we get the corresponding point value, and then we are now going to specify the icon. And then the color will be green. And then, sorry, the background color will be green and the foreground color will be white. See if I can make this neater or create some space for us. Okay, so we have icon, pop-up, and the suburb location. And now, so the foreground color is white, and then the type of icon that we're going to be adding I will change that to, we are going to give it a thumbs up icon, meaning that it is a good consumption value. So we use the thumbs up icon, which is almost like a like button icon. And then we are going to specify the angle, which is 0. And then the prefix will be FA for font awesome. And then we are going to add that to our map, the OpenStreetMap base map. And now we are going to do the same thing to our second base map, which is the dark matter base map. So let's copy that code. It will be exactly the same. Okay. And then we are going to add the second condition. So we have the first condition, which is if the kiloliter value is less than 5, then plot the map, plot the icons on the map in a green color with a thumbs up icon. And now we say elif for our second condition, which will use the same code. So we can just copy that. And then we say if that value is greater than 5 and if that value is less than or equal to 8. So it's less than or equal to 8. So 8 was the mean consumption value. Let's just check if that is correct. Okay, and now let's add the code again. I'm just going to make some space. Okay, so we can copy the same source code. And now we change the color to blue. And we leave the icon to thumbs up. So that is still a good amount of water consumed by that suburb. So it's not above 8 kiloliters, so it's still fine. We'll leave them both at a thumbs up. And now let's add our last condition, which we'll just say else. And then we can add the same code. And now we give it a thumbs down. And then we change the color to red. Save some space. Okay. And now, if we haven't made any syntax errors, let us first plot our OpenStreetMap map. So I'll say map OSM, shift enter. And as you can see, we have managed to classify our data points. So all the suburbs are classified based on the amount of water that they have consumed in kiloliters. And we can clearly see on the map the suburbs that are using too much water are marked in green and they have a thumbs down. Those that are using a reasonable amount of water have a thumbs up, and those that are using very little water have a thumbs up as well, and they're marked in the color green. So as you can see, it's clearly visible that the time this data was published, we had a serious water crisis in Cape Town. And as you can see, we can clearly see that a lot of suburbs were using too much water as well, right? So the next thing that we are going to do is we are going to see if we have plotted it correctly on our other base map, the dark one. So that's map dark. So as you can see, we have successfully plotted on that map as well. So thanks a lot for tuning in, and I'll see you guys in the next video.